Hey guys, Rob with Trophy Hunter Supply again. Had some questions come back up and some guys looking for a little more in-depth video on mechanical advantage. So we're gonna go through pretty much the entire thing. I've got it set up where we'll be able to see the broadheads going through the material this time. And I kind of corrected some of the additional variables from the previous test. So changes, we're not using cardboard this time. What we've got is actually leather. So should see some lower numbers overall, but what this is going to change is instead of just being able to press through the cardboard, there's, the sharpness of the broadhead is definitely going to play a factor. Now, I'm not going to have this like super tight. It's going to be pretty much hung. I'm going to tape it here, and then it's going to be a little soft. Now, if you've ever tried cutting something, you know that the tighter a material is, the easier it is to cut. When we look at the animals that we're hunting, their skin's not tight. It moves, it stretches. It's not stretched tight. So, just trying to simulate that a little bit. Got a different arrow that I'm using this time. This is a 175 Momentum UFOC, so very stiff shaft. We'll have less flex, less variable in that when pressing. I also expanded the broadhead selection a little bit and went through and recalculated all of the mechanical advantage numbers. So just as a reference, I'm going to grab a couple of the kind of goofy ones to demonstrate. So like with this Helix, what we got is two different mechanical advantages. And now there is a way to mathematically calculate what the true overall mechanical advantage is, but you don't need to. What you're looking for is a reference number. So on anything like this, where there was multiple mechanical advantages, we're looking at the worst. We're looking at this. What you're going to do is go from, it's tough to do backwards here. If you take that line and figure out where it would cross center, measure to that point, right? And then for the two blades, you're doing your cutting width divided by 2. For the 3 blades, anything else, you're going to be going center out. So any of those heads, we took the worst mechanical advantage. So I mean, that's like with the Fixpandable. We took the expandables, and yes, that's going to be a factor, but that is a much lower mechanical advantage. So that's the number that we took. Same thing on like these two. Both of these have bleeder blades. So we're disregarding the bleeder blades and just calculating the main blade's mechanical advantage. Now, when we look at the applied force required to get a certain amount of work done, which our work is cutting through this leather. So to accomplish that, there's going to be a handful of other factors that come into play here. The sharpness of the broadhead, the style that the edges, which also plays into the sharpness, but I've got one here, this blade from Carbon Express, that it actually is a serrated edge on the main blades. Now this is fresh out of the box, and that's all of these are fresh out of the box, except for a couple of our two blades, which have been through some targets, well, pretty sure that a couple of these have been through some animals. But any of the expandables are fresh out of the box, or never been shot. So they are as sharp as what you would get if you bought a pack. So that's going to come into play. The bleeder blades, and those are going to come into play. The other thing that I just kind of want to bring up is, if we look at, I'm just going to use these two as an example. They're close, but this Ashby is forged. Now, the mechanical advantage also comes into play, how efficient it is with how clean those lines are, where it's coming off of the blade onto where the ferrule is, how clean that is. So now this is a little less efficient because it's a little steeper of an angle to get on here. But if you're really wanting to look at efficiency, those are the kind of things that you're wanting to look at. It's not just the blade angle, it's the blade angle and how the blade relates with the ferrule, all of that. So let's get into it here. This is already going to be a longer video with doing all these heads, but just jump into it and see where things go. Now, I really don't want to look at what it takes to open it. I'm wanting to see what it takes with the blades open. So we're going to try and hold this open. As you're probably kind of starting to notice, when it comes to material that requires more cutting and not just, brute force. I mean, cardboard, you could take a butter knife and push it through, right? Now, taking a butter knife and trying to push it through leather, it's going to be a bit different. So that's, as you're kind of starting to notice here, there is definitely more factors at play than just the mechanical advantage. The mechanical advantage definitely plays a big part, but there are quite a few other factors that can definitely alter your results and alter how well it works. But you want to take it all together, because once you get through that hide, you are going to be going through all the muscle and sinew and fat, and that's where that mechanical advantage is definitely going to be a factor. You know, the sharpness and how well the blade stays sharp is going to be a factor, but you know, it's all together. You want to kind of consider it all and consider how much force are you actually putting into the arrow. You know, depending on your bow setup, depending on your draw length, depending on your draw weight, you know, how much force are you actually putting to that arrow and giving it to use. If it's not a lot, if you're, you know, setting up one of your kids, and Wisconsin, it's a 30-pound minimum draw. So you don't have a ton of force to play with there. But if you're like my bow, I'm 70-30. So I've got a lot of force there. I could make do with a lot of different setups for whitetail. You know, I mean, you see it every day that some of the heads that people think are the worst work. You know, it's a matter of when push comes to shove, how much is it going to do for you, and is it going to do what you want it to do? That's really the main point of all this, is just to have people be aware and know, is it going to do what I want? Is it the best option for my setup? So much of this is that tip design. That's such a big factor in why I am a big fan of anything that's cut on contact. That's the Ramcat is a great head. It's actually one of the, if I was picking a 3-blade, it'd be one of the heads I'd be looking at. But that's the one thing that kind of turns me off of it, is that, you know, it's a tough head, but I like having sharp edges right away, like this one. For those of you that don't know what this is from Valkyrie. It is a 3-blade, 250 grains, and it's just kind of wicked looking. We had 11.62. Yeah, so I'm just going to walk this one up to make sure that you can see that. That's 0.51. That is phenomenal. Now, that is also cut on contact, pointed tip. There's no, like, that just drops through. So I'm pretty sure the weight of this on the arrow is like 0.2. So that's fantastic. So I know on the last test I had a modified Ashby that I had ended up bending on a rock and reworked, and this is what it's actually supposed to look like. And the new winner. I was kind of expecting that. Those things are wicked sharp. So that's 0.46. So, just some last comments here before we wrap up. Now, I want to show you a couple of things. So, both of these were, well, the Valkyrie was at what, 0.51, I think, and then the Silver Flame that we just did was at, a little under half a pound of pressure. Now, both of these are very pointed, cut on contact, and they both are very high quality steel, very easily sharpened, and they retain those edges very well. Now, this is a phenomenal mechanical advantage. It's a phenomenal steel, wonderfully sharp, but to increase the durability of the points, if you look, even let's get rid of the Valkyrie, and we look at those two. This is truly pointed. This has a tanto tip. So what this is instead of having that point, we actually have two flat, not flat, but as you can see, ground edges on that point. What that does is it increases the tip strength. It reduces that tip from curling and bending, and that's part of what, when you're picking out a broadhead, that's part of what you want to consider. Even this, I like the design of this head, especially for a 3-blade. It's phenomenal mechanical advantage. This was at 1.5, which for a 3-blade is phenomenal. And if they didn't have these flares, it would have been drastically higher than that. But I know that with that tip design, it's going to do phenomenal in flesh, but I know that there's definitely a tendency for that to curl. Even though this is very high quality steel, very good Rockwell hardness, that tip design is going to have a tendency to bend on hard impacts, on square bone hits, and that's part of my selection process. Is I'm looking at the best head that I can get that I trust to have the lowest amount of failure. And honestly, that's why I run this. I know that this is a better mechanical advantage, but because of the straight edge here, less material up on this top, even with the Tonto tip, that is slightly weaker. If I'm buying my stuff, I want it to last. I reuse my broadheads. And so this, even with it being an overall wider design, it still has that Tonto, still improving the structural integrity of it.